Excellent.
Hey, what's up, folks? Welcome back to another 3D Hangouts special edition with Liz Clark. Liz Clark is joining us today.
Hey, thanks for having me.
Yeah. We got a really crazy show packed. As you can see, our second camera set up. We have a lot of audio gear set up. Welcome to the show. It is episode 487.
It's a lot.
It's a lot. It is June 18th, 2025. We're streaming on all the usual places: Facebook, LinkedIn, YouTube, Twitch, and X. If you'd like to drop us a comment during the show, questions, gifts, memes, all that and more, we can bring them in the show. We can answer questions as we go. I do want to give a shout out to all the lovely folks that are hanging out in the Discord chat. Give a couple of moments for folks to come in. Shout outs to Squid.jpg, Jim Hendrickson, and Do Wester. Hello. We have a special treat for everybody. Pedro sends his regards. Yes. He is on special assignment. He is in the midst of doing some kind of secretive stuff. He is working, but he's taking the day to work on that. But it gave Liz an opportunity to come in and talk about this week's project, which why don't we talk about? Why don't you show it on the overhead? We can talk about our latest collab project.
Did we want to talk about freebies and things?
Yes, we did. Okay. Yes, that is the way we do it. Thank you very much.
No problem.
All right. For folks watching the show, we have a special coupon code. This week, it is Solenoid. I wonder why.
Can't imagine.
I can't imagine why it would be Solenoid. So if folks, you want to put your orders in today, please use our coupon code. We appreciate it. And it'll get you 10% off anything in the Adafruit shop. Solenoid at checkout. Also, adafruit.com/free. We like to give you free things for different tiers. Starting at $99 or more, you can get a free PCB coaster.
It's very pretty.
It's very pretty. It's got a golden Adafruit logo. And if your order is at $149 or more, you're going to get the free PCB coaster plus KB 2040.
I love a KB 2040.
Yep. If your order at the top tier at $199 or more, you get the KB 2040, the PCB coaster, and free UPS ground shipping for continental US only. So while you're at checkout, why not use your coupon code Solenoid?
Yeah.
All right. We also got Vince. Hello.
Hi.
Nikita on YouTube, and Shujat is also on YouTube. Hey, folks, thanks for joining us. Okay, I think we're ready to talk about this week's project.
All right.
Solenoid me.
Yes. So we worked on this project. The cable's a little short.
Yeah, you can unplug it. Yeah.
Okay. So this lovely little typewriter is not a typewriter.
No, it's not.
Not a typewriter.
Yeah.
But what it is it's a USB host.
Why don't we show it here, actually? Because then you can keep the mic here.
Of course.
Yeah.
So this is not a typewriter, and it has USB-C here, but what's over here? USB-A, because it is an RP2040 Feather USB host inside. And it's connected to an I2C Solenoid Driver. And there's 2 solenoids in here, and you can use it to bring the vibes of 1960s writing the typewriter to your current modern day setup. When you're typing along, the solenoids clacking along, and sometimes on special keys like Enter, Tab, you'll get the ding of the bell as well.
That is right. So Liz, by folks that I guess don't know, Liz Clark works on all the product guides. One of the recent product guides was the Solenoid Driver, 8-channel I2C Solenoid Driver. So you worked on the product guide and not quite a library, but
no, the driver already existed because what's cool about the breakout is it uses an MCP 23017 GPIO expander, which is fairly ubiquitous. You've probably used it. It's available often as a through-hole IC, and this version of the driver has it right on board. And then there's circuitry to be able to drive solenoids with it. It has I think it's a flyback diode that's the circuit for it. And so what this means is with the terminal blocks, you can drive 8 solenoids, no soldering required, all over I2C. And if you've ever had to hook up the circuit that would usually be required to do this, you'll know this is kind of a game changer. So in using this, you can easily look how small, so small, with these solenoids inside, whereas before it would be pretty big.
Yeah. So we just published the Learn Guide this morning. So this is, of course, the collab project. You worked on the code,
Yes.
and I worked on the 3D printed case.
Yes.
So check it out. I want to give a big shout out to kind of the project's inspiration. A person on X called Tetora Tech's Lab published a video of their fake typewriter, and it's using 3 solenoids, an Arduino Nano, I believe, and some like a perf board thing.
Yeah.
So check their project out. We were really inspired by it, and it just happened serendipitously that Lamar was releasing the Solenoid I2C Driver breakout, and we were like, this would be a really good project to like showcase the Solenoid Driver, and of course CircuitPython with USB host on the Feather RP2040.
Yes.
So big shout out to Tetora for inspiring us to kind of remake their project. And then I struggled a bit with this project, to be honest. From a mechanical standpoint, it was so I found this this bell, like the hero of the thing is this bell, right? So the service bell, it's kind of hard to get a really good sound when you don't do it right. So I don't know how deep I want to go.
Well,
it basically, like, the way I was mounting the bell came up to being like keeping it loose. Normally when I'm mounting things, I want everything to be nice and tight and secure, but with this, because you're having to deal with sound resonance, you kind of have to have it loose. So in this GIF here, you can kind of see that it's shaking back and forth, and that's like very necessary to get this thing to ring. So
and that's something I've run into when I've done the robot instruments. I've done 2 robot xylophones, and you have to be able to strike it hard enough that you're getting a sound, but also let it vibrate, let it resonate. And that's really tricky because it can literally be like 0.2 millimeters can make a difference.
Absolutely. And that's what I found.
Yeah.
In Tetora's project, you can see the solenoid is like striking it on the outside of the bell. The trick here was getting it on the inside. It's very tricky. By the way, the solenoids are the Mini 5-volt solenoids.
Little bubs.
Yeah, they're very small, but they're nice to work with. So this was like the perfect solenoid. We tried some of the bigger solenoids at first, but we really wanted this thing to be powered all through the USB power.
Yeah, and
that required this one. So it's a nice solenoid. It's perfect for what we're doing. It has like a little mounting holes that I can actually secure it to. You do have to tap the screws, but that's fine.
They're like M2.
They're M2. Small. They're very, very small, but that's the whole kind of thing about it. So,
and you can see that circuit there on the breadboard.
Yeah.
That's what I'm talking about with that breakout. All that circuitry is taken care of for you. So it's literally just plug and play. You don't have to worry about the polarity of anything or worrying about pinouts, which I've run into before.
We'll talk about that. And it comes with the JST connector. So in our circuit, we were just using a what do you call it? A JST extension thing to plug and play, and then we just screw that into the terminals. There it is, right here. These little guys here. So it was kind of easy to plug them in. Yeah. And for me, when mounting it, it made a lot of sense because now I don't have to like solder while the thing is threaded through the case, which I've run into before. So it's nice to have these connectors. And here you can see with the battery. But yeah, that's kind of the gist of it. Why don't we plug it in and we will annoy everyone with how it sounds.
They're gonna love it.
Yeah, you're gonna love it. So
nice. Okay, plugged in.
All right, it's plugged in. Somehow it's now a MIDI controller.
Oh,
wow,
good.
Look at that. And let us know if we have any audio issues. Yeah, without a driver, 5 volts. Yes.
Yep.
Okay, so I'm gonna go into my terminal app and run the thing. So now I'm typing, and when I hit tab or enter, you get a nice ring.
Yes.
Let's get it closer to the mic.
Okay. Oh.
Yeah. Why don't you
Good
show
morning.
it? Good morning. Yeah. So so tell me about the features that you've programmed into it.
So there's two ways you can do the code for this, because we want to have kind of two methods for people. The one that we're doing right now involves running a Python script on your computer that is listening for all your key inputs. So that also means you could use this with like a laptop as a built-in computer. So it's actually the next page.
Yep.
And then this kind of plugs in and has a boot.py file that lets the Feather also have the USB-C port. And so that means that the CPython script can talk to the Feather over serial, send all your key presses to it, and then the CircuitPython code is listening for those those key codes, and then is triggering solenoid or the bell solenoid, depending on what it's getting. And that makes it really portable. And the script can run just in the background on your computer.
Yeah. Yeah. So Liz put together a nice code breakdown and everything you need to put this together. Anything interesting that you want to pull out? It works on Windows and Mac.
Yes, I didn't test Linux, but you Linux people can figure
Yeah.
things out. You're good at that.
Sure. Yeah.
But it should work. Python's pretty portable. So I have that GIF there is just showing all the keystrokes coming in as I'm typing. So on the right side is my terminal running the Python script, and then the bottom left is the CircuitPython serial monitor. So you can see it's pretty responsive and just
Very
doing
responsive.
some typing.
Yeah.
All work and no play makes Jack a dull boy.
Yeah. Very good reference to a very creepy movie. Yeah. So let's say we want to turn our regular chiclet keyboard into a typewriter.
And let's also say maybe you don't want to run a Python script on your computer. What this does is it's totally running on CircuitPython on the Feather, and it's using USB host. And what's happening is you plug in your USB keyboard to the USB host Feather, and then as you type, the Feather is taking in those key commands, and it's triggering the solenoids as needed, but it's also sending all your key commands over USB HID. So it's also acting as an USB HID device. And that means the Feather's doing all the work, all the lifting. And big shout out to Tim Foamy Guy, because he has a guide where he talks about how to use USB hosts with a keyboard in CircuitPython. And I was able to build on top of his example that's basically doing exactly what I was trying to do, which is like listen for all the key inputs. And then I could just adjust the code to add in like, okay, well, when this key command comes in, I want you to strike the solenoid. I want you to send it out over HID. So this is a really good guide. If you want to do anything with USB host in CircuitPython, you can kind of use this to build on. Because personally, I've always been a little confused by the API with the USB host in CircuitPython. So this made it really easy to be like, okay, this is how I do it.
Nice.
Yeah.
Shout out to Tim. Cool. All right. Is this your first USB host project? I think you've done one before.
I've done a few, but this was my first CircuitPython USB host.
Okay.
I've always done Arduino before.
Okay. Now let us know if this becomes annoying, because I'm using my keyboard and it's obviously working. So every like keystroke I make when I'm switching between tabs, you're just going to keep hearing a bell ringing or if solenoid's striking.
Great.
So let me go ahead and hit escape, because we know it is annoying, and that's kind of like the point of it. It's just a fun, silly kind of demo to show that you can get pretty crazy with CircuitPython stuff.
Yeah.
Cool. All right, I'm gonna take a moment to look at the chat here. Let's see what we got. It's not real if it's not isn't annoying. Okay, Duester. Steampunk computer in the future. Ooh, yeah. I type so loud that I don't need the bell to annoy people.
Fair.
Yeah. This is for like those MacBook laptop chiclet keys. That's a great use of
and
it.
that's one of the reasons why we did the version with the CPython script. If you're on a laptop, you gotta let people know you're typing with purpose. So
right.
That lets you do it.
As if my model MCLAC keys weren't loud. Yeah. We know a lot of people like your keyboard's already annoying, so that's why it was good to show it with like non loud keyboard. So
Yeah.
turn your loud non-keyboard into a loud keyboard.
Yes.
Okay, let's hop back over to our Learn Guide, and we can kind of talk a little bit about what else. So, the overview has all the parts. I think, thank you for buying out the solenoid driver, folks. It's out of stock right now, but we're working on making more. The feather is in stock. We got the keyboard if you need a keyboard, stemma cables, all the wires. And of course, the solenoids. These were out of stock last week, and this week they're in stock. So that's nice to see.
Yeah.
And just a couple hardware bits: M2 screws, M25 screws, and the small bell is, purchasable on Amazon, which is like $5 for 2 of them. So I have a spare one now that I don't know what we'll do with it. Maybe we'll train our cats.
The cats will use it. Yeah.
Yep. As far as the circuit diagram goes, pretty easy. You plug and play with stemma QT over I2C. And then we're using the USB pin and the ground pin from the feather to power the solenoids.
Yep, you get 5 volts.
You get 5 volts, and the solenoids just plug into the channels. And it's easy to hook everything up.
Now, do we want to talk about other solenoid projects we've done where the wiring was not this straightforward?
Sure. Which one would you like?
How
about your most recent?
Well, that's the most recent one, and
which uses the solenoid driver.
Yes, this was a toy piano xylophone here, and it made the wiring super simple because, again, I used the Metro so that I could get 12 volts in from here and power the Metro, and also get VIN out to power the solenoids, and then everything's able to be nice and compact and just screw block terminals in for the actual solenoid motors. But in years past, when we've done a solenoid project, it would be kind of a big undertaking because if we go to this one, you can see that so this is the drum one, I think.
Yeah, this is drum one. Did you want to look at this one then?
Either way. So look at that.
Gosh.
Look at that.
This is pretty intense.
But it's kind of the same circuit because it's using those GPIO expanders that are over I2C, but obviously it's not stemma. And then it's MCP, I think it's 2308 drivers for the solenoids. So this is like all through hole, all like using perma proto. Yeah,
this is
a lot.
Intense. Yeah.
Whereas if I were to redo this today, I could daisy chain a bunch of the breakouts and the end.
Right.
So it's definitely evolved.
Yeah. And so there's that one, and then I forget which
it's that
at some point. This was a little bit easier, I think.
Yes, this was
not as many. It's just one ULN 2803A.
Yes.
Which is a GPIO expander?
No, it's it has the circuitry to drive the solenoids from like your standard like GPIO logic level. And so there's circuitry inside the IC that drives it. But also when we were talking about this project yesterday, because on our walk we were just kind of talking about all the solenoid projects, we both kind of had collective amnesia about this project because it was like summer 2020. And as we know, things weren't going well.
There's the part shortage as well as, I think I had to order these from like DigiKey or something. And it was a strange time.
So
kind of in the same vein that you're using a solenoid to strike a thing. This was a little bit challenging too on my part because I had to create like linkages for and like the 3D printed mallet and different solenoids for different things. I think.
But I liked your DC jack method of plugging them in.
Yeah, it's kind of interesting. Yeah,
I think at the time there was a MIDI product that was available commercially that was using the DC jack.
Oh, that's right.
Plugs.
I completely forgot about that. Yeah.
It's all coming back.
Yeah. Huh. Yeah, a lot of hardware.
Yes, a lot of hardware.
Yeah. Things have gotten easier.
Yes.
So this was your recent
that was
first project with the
it.
I2C Solenoid Driver. You used all the channels, right?
I did. Yeah. So that's with one you can drive 8. So and luckily the keyboard had 8 keys. So perfect.
Yeah, different solenoid, but
12 volt. And that's why the Metro probably is like are using the Metro, you need that main GPIO, but it has that DC jack to be able to use VIN from it for the power in the solenoid. So it keeps everything nice and compact.
Yeah. Cool. All right. I saw one question. How does one charge the typewriter? So it's getting power from your USB hub from your computer. So I just have it plugged into my desktop here.
Yeah.
In the GIFs, you can see it plugged into the MacBook, and also I plugged it into the iPad.
Yeah.
iPad has USB-C, so just C to C, and it powers it just fine. It sees the Circuit Pi drive, which you can edit and stuff, which is pretty cool. And iOS, iPad OS, whatever. It tends to support it pretty good. So yeah, no need for batteries with this one because you're getting USB anyway.
Yep.
Make some noise for the crazy toys. Yeah, we're not there yet, but you probably saw our camera setup. We have like a bunch of MIDI synths and weirdness going on. We don't have notes as that many solenoids. What are they used for? Yeah. Maybe rephrase the question. I'm not understanding.
Yep.
Let's see. Solenoids life reminds me of the room from Meow Wolf in Denver, where they have a whole room of automated instruments. That sounds awesome.
Nice.
Yeah, we love robotic instruments.
Boston Museum of Science, I don't know if they still had like a display that was all kind of robotic instruments in like this big tower. And it had kind of a similar vibe of like all these motors and everything chained together.
Okay, Nikita's asking about this. Sorry, I have it here. Yeah, the xylophone. Check it out. Yeah. 8 solenoids, 8 piano keys / xylophone keys.
Strikes them all.
Check it out. Yeah, you can read all about it. It's instead of striking the metal itself, it's striking the buttons.
Yeah.
Strike the thing because it just sounds better actually.
Yeah, and I hadn't done that. There's like quite a few robotic xylophones, and where I'd already done one, I kind of wanted to use a different instrument just to demo it.
Yeah.
So.
Yeah. Cool. All right. Let's see. What else can we talk about this project? We kind of covered everything. I can talk about the 3D case.
Yeah.
I just thought it was a cool idea to do the typewriter enclosure. Yeah, we got one solenoid mounted inside the enclosure, and then the other solenoid is like mounted on top of it where it's under the bell. So kind of modeled everything around the bell, really. And of course, around the feather and the solenoid driver. I just got lucky with how they kind of have similar widths.
Yeah.
So if you can see here, actually, let me go to just my screen. Yeah, it's actually perfect aligned with the solenoid driver.
Yeah.
And just enough room for the stem QT because it's on the side to like kind of fit upwards. Why don't you unplug it so we can show off?
Yeah.
Sometimes I end up doing things where I need to like create a kind of indentation for the USB so that you can get your cable in there. So I did that here. And then for this, the USB-A port, I have a little bit of a lip here that just kind of closes off. So it's a part of the bottom case. And these parts snap fit. And
do you want to talk about how you made the Not A Typewriter?
Yeah, so we have the AMS system for our Bamboo Labs Carbon 1X, X1, whatever it is. So I was able to create dual extrude parts within Bamboo Studio, which is the slicing software for the Bamboo Labs. So I was able to dual extrude these things, not dual extrude, but multi-color print these. And this was my first time creating text inside the Bamboo, which I found really easy. Of course, you can do this in like your CAD app, but it's really nice to do it all within Bamboo Studio because I can preview how the how it slices. That's a big deal because like sometimes I'll like export something and you think it looks one way, but then when you slice it, it's actually some of the lettering isn't like fully rendered or fully like extruded. So this was my first kind of test of doing like type, and it worked out really well. So you can download the 3MF file and it has the text stuff. I think it'll also work in Orca Slicer because it's using the same engine. But that's another reason why we switched from STL to 3MF, because you can have all that data in the file where like all this is like editable. The color data is there, so you can change the colors and it'll kind of import and have all the slice settings for you, which is pretty cool. So yeah, that's how I was able to make that fun little detail. And of course you could do this with like a regular filament swap. But I was able to just kind of tell it what color I want to print the keys in. So that was kind of cool.
That's great.
So yeah, having the ability to have these little details and now text is like really, really cool. So yeah, it's a really nice thing. So that's the enclosure design. Let's see here. Yep, so I have all the 3MF stuff. I have a step file if folks want to modify it, and the Fusion 360 file as well. Of course, we do have 3D models of or Adafruit parts, like the Feather RP2040 USB host and also the Solenoid driver. So I have a model of that as well.
And I've been trying to be better about, as I do the product guides, I do a issue for the part. So then Noe knows like, okay, there's a new part and the PCB files are available. So then the part is added to the CAD parts repo as the guide's done. So that's how we're able to kind of stay on top of it.
Yep. So if we go down to the downloads tab in the product guide for the Solenoid driver, you of course have access to the data sheets, the schematic, the Eagle file, and now 3MF, 3D. Step, and Fusion 360 with all the parts laid out there, which is nice.
Nice.
Cool. All right. I think we'll skip some of the nitty-gritty stuff like the wiring. Of course, we have everything laid out and documented. So wire lengths are, of course, important when you're making a small, tight, spaced enclosure. Taking apart the bell is like a 3-step process. It all snap fits together. So I chose a really good bell because it would have sucked if things were glued. So I just kind of won the maker lottery with this one. Like I just found one. It was the right size and I could disassemble it, but we don't actually reuse any of the plastic parts. We're just fitting it on top of our 3D print. What else? Tapping. Like I even covered tapping the holes, which is, I guess, important because like otherwise it's not going to work. Yeah, and everything's all in the right order, and that's how you build it. Whee! Yeah. I think that's kind of it. So if anyone has any more questions, is it modular? Can it work with IoT? Not at the moment, because the Feather USB host just has USB host.
Yeah. I mean, you could, we have some Trinkies that don't have Wi-Fi, but have like logging capabilities. So I've written CircuitPython scripts to like demo how you can interface with Adafruit IO with them. So you could like write a Python script that is, talking to the typewriter that, if something came in online, then you could have it ring, but that would kind of be taking it further. Right now, we don't have any like code built in that you could run with it, but you could totally modify what's available on the Learn Guide. Yeah,
you can connect any Feather to or a QT Py, like a ESP32 QT Py.
Yeah.
Connect the driver over Stemma QT, and then you could ring a bell every time you get an email or something.
Yeah.
That'd be a fun one. Yeah.
That'd definitely be cool.
That would be a fun one. Yeah.
Yeah. And we have we've done other projects where like I know I worked with JP on one that was like it was back when you couldn't get Raspberry Pis, so it was connected to the Twitter API and it would like ring a siren. Like so like the skeleton of the code is definitely there. You could modify it for your needs.
Yeah. It'd be cool if we get at some point we'll probably get whippersnapper support for the Solenoid driver.
Yes.
So
that'd be great.
You get some data or a feed gets updated, the bell will ring.
Yeah, that'd be good.
So that would be cool. Yeah. So yeah, there's lots of cool things you can do with the Solenoid driver and any mixture of microcontroller. Cool.
Yeah.
All right. Squid.jpg is shouting out the CAD repo. Thank you.
Yeah.
And Dubus are saying there's 10 versions of the ARP2040 and none is a USB-A. Other than our Feather host, I guess. Yeah.
Yeah.
Okay. Do we have a Feather Wing host? Do we have a Feather
Yes, Wing? It uses the Max. I forget the numbers, but yeah, that. Yeah. There's also a BFF for QT Pys with it too.
Yeah. So if you
Yeah.
wanted to add USB-A host
Yes.
to whatever feather, this would be your thing. And here in the photo, we have like an ESP32 feather with a TFT.
Yeah. Technically, that Trinky there is USB-A because it's the
Oh yeah.
PCB USB connector.
Mm.
But yeah, that's so that featherwing works over SPI. So it's pretty common to pair it with an ESP32 family board. So you can add USB host really easily. Whereas the RP2040 has the PIO USB support. So often we'll use it like natively with that.
Looks like you used it in this USB
I
host
did.
to BLE keyboard adapter.
Yes. And that's kind of a similar concept to the typewriter, only it was written in Arduino, where it's taking in the USB keystrokes and then using the ESP32S3, it's sending over Bluetooth. So the feather is acting as a Bluetooth keyboard. That's how like my device is seeing it. But then the code is taking in the USB keystrokes and sending them over Bluetooth.
Pretty cool.
Yeah.
All right. Plenty of fun USB host and solenoid projects.
Yes.
Yeah. Okay. Oh, in his collection.
Oh, I see.
Yes, I see. Yes.
Okay. Transparent displays. Yeah, I've seen them. I haven't used them. I have
not played with those yet.
Yeah. I know. I think someone used it to make like a recreation of a Lego display.
Oh, that's cool.
Yeah. And then some people have also used them on top of the keys too. So it's like a keycap with a display.
Huh. That's cool.
Yeah.
Okay. All right. That is the Solenoid Not A Typewriter.
Mm-hmm.
It is not a typewriter.
Not a typewriter.
But it sounds like a typewriter.
Yes.
Okay.
And,
so check that out.
I do want to take. I was really proud of myself that I was able to reference Hunter S. Thompson and Mad Men and.
Yes, please read
Yes.
the overview because Liz is very proud of it.
Yeah, I always like when I can get references to things.
Yeah. Okay. Cool. And again, shout out to Tutora for their inspiration.
Yes.
Very cool project.
Yeah.
We
their video is really cool too.
Yeah. Yeah. It's all in Japanese, but you can decipher what's going on just by seeing the demo. Yeah. Cool. Yeah. We always love, citating or giving reference to our inspiration in our learn guides that heavily take on it. All right. I still want to know, where did they get that bell? That tiny little bell. It's very cute.
So
I don't know where they got it. I think maybe it's from a real typewriter.
Probably.
Yeah. You ever used a real typewriter?
I think when I was a little kid.
Yeah. I think I have a vague memory of going to like a thrift store and there was a typewriter and typing on it.
I think I had like a kid's typewriter.
Yeah.
Like, yeah, I have this vague memory of it.
Kid's typewriter.
Yeah.
Wow. That had the ink ribbon and everything?
I don't know about that. That's what I mean. Like I remember typing on something, but I don't know what it was.
Yeah, I think the one I typed on didn't have any ink, but it was still like.
And then the like oldest typewriter repair shop was in Cambridge, which is right outside Boston. It's where Harvard is, and it just closed down. It was like a big thing. So if you're into that kind of stuff, definitely look up the story of that shop because it's pretty cool.
Okay, and that's the history of typewriters. Okay. All right. Elephant in the room.
Yeah.
What is going on? Why do we have a synthesizer, a MIDI controller, and another MIDI controller, and just cables everywhere? What are we talking about here? Yeah.
So you and I both do a lot of stuff with MIDI and electronic music, and the most annoying thing in that world are the different MIDI standards. Because once you leave the world of USB MIDI and you're doing hardware MIDI over UART, you've got the DIN5 connector, which is the big chunky one. But then you've also got TRS MIDI, and there's not really a standard for that. There's TRS-A and TRS-B, and all it means is that the two signals are swapped. And it's always hard to know which device is which and trying to get them to talk to each other. It's very frustrating. So I had this idea to make a PCB that would let you kind of send the signals around depending on what you had. So I wasn't sure if it was going to work, but it did, luckily. And so on the PCB, there's signal. I wired up for TRS-A, DIN5 MIDI, and TRS-B. And I just added the 220 ohm resistors, which is the circuit for MIDI through, because that's what we're doing. We're passing MIDI through. And then using techniques that Lady Ada talks about on The Great Search, I found a switch that was a 3-way switch. So then I can say like, hey, I've got this TRS-A MIDI signal. I want to send it over to the DIN5, or I want to send it over to the TRS-B. And I totally can. And I also did a PCBA with JLC for the switch and the resistors. I can totally solder that, but like I didn't feel like it. So then all I had to do was solder the through hole. And then because I like a joke on a PCB, I did a silk screen with the switch card from Uno on the back.
That's very creative.
It's kind of like sending them all around.
Yeah.
So I guess
so
we can...
so the idea is that like, you know, we don't need a special cable that goes from DIN5 to TRS-A or TRS-B. So you can kind of mix and match whatever cable you have.
Yes.
And just kind of switch it on the fly if you need to. Another cool thing that I found is that now I can have one MIDI controller controlling 2 different types of MIDI things, and I can just switch it on the fly.
Yes.
So that was a cool demo.
It's also passive.
And it's passive. Okay.
Yeah.
All
so you don't need any power to have it work.
Yeah. So why don't you show this off in front of the camera just to kind of talk a little bit of the detail. That's an unpopulated one, kind of unpopulated.
Yeah. So we've got an unpopulated one here. And I don't know if it's
I can focus, I believe.
Focus?
Yeah, let's see if I can.
Maybe.
There it is. We want it to be close up. There you go. That's good.
Yeah, so
a little bit further down.
A little further down.
Yeah, there you go.
Okay. So you can see on it, there's the spots for the TRS jacks 3.5 millimeter here, and then DIN5 here. And then these switches can go to 3 positions.
It's hard
to like restart.
I know, right?
So sorry, folks.
It's okay.
I don't normally do a live show.
Yep.
And so these switches let you route it to different spots. So TRS-A here, DIN5, TRS-B.
Okay. So now talk about come on, wake up. There you go. So let's talk about the gear that we have set up here.
Yeah.
So in this demo, we have a kind of a tempo pad, which is a MIDI controller. All it's doing is just controlling MIDI.
Yes, and that uses TRS-A.
Yes.
Which has kind of become the default standard, I feel like, for TRS gear.
Okay. That's the blue cable.
Yes, that's the blue cable.
Yeah.
And it's going into the TRS-A input here.
Yes.
And then we have the Arturia beat step, which uses TRS-B because of course. And that's plugged into the TRS-B input here. And then we have a Korg, micro Korg synth, which uses DIN5 MIDI, which is at least a little bit more standardized. But still, if you wanted to use it with any of these things, how are you going to do it? So then we've got the DIN5 output here to the Korg MIDI in.
Yeah.
And so with this setup, you can control the Korg with either of these and just do it really easily without having to think like, do I have the right cable? Do I, what am I doing? So.
And the Korg is the only thing that's making actual sound.
Yes.
So we have the sound coming out into our desktop's audio interface, and we'll just do a demo. So it's going to monitor it. This is a very hard thing to set up just as like a background. We'll talk more about it, but go ahead and demo it for us.
Okay, so I'm going to press play on the Arturia, and you can see it's routed to go to the DIN5. So I'm going to press play. So that's sending a sequence over TRS-B MIDI. The switch routes it to the DIN5 MIDI, goes into the Korg plays. And I can switch up the sequence too, just for some fun there. And that's an empty sequence, so.
All right.
Yeah, so that's a TRS-B. And then this,
turn it on, please.
Okay. So now this little tempo pad here is going out TRS-A to here, and then I'll flip the switch to the center, and then
Click on the B button, the B bank. Yeah, right there. That'll give you some more chromatic notes. There you go. Yeah, so
Yeah.
I'm a finger drummer, and I really like the pads on the MIDI controllers. So for me, it's actually really useful because now I can like kind of do this like custom mapping of MIDI and not have to worry about the keys on the Korg.
Yeah, and then I think I can have both go at the same time.
Yeah, let's. And then you can just
maybe not.
There you go.
Oh, it's interesting. It cancels it out.
Really?
Yeah.
What do you mean cancel?
I don't know.
We'll play around with it a bit
Yeah.
more, but maybe it wasn't playing it because you have to play something through here, right?
No, when I hit the switch, it like cancels it out.
Let's do what it's supposed to do.
I can't. I can't have both.
Oh,
yeah.
Yeah, I didn't think you could do both. It's
You
just
don't
one
think?
or the other, right?
I don't know.
Huh, interesting. Well, this is the first time like demoing it actually
Yeah.
with the two controllers.
Yeah.
But it is doing what it's supposed to do, right? Like I want to
Yes.
control the signal is coming out
Yes.
from the finger drumming pad
Mhm.
and also the Turia
Yes.
sequencer. So what is this thing called? What are you calling it?
I called it MIDI Roundabout because it's kind of like a roundabout when you're driving, going all which ways. And then also there is a song by a band called Yes from the 70s called Roundabout, which is heavy on keyboard. So I was also thinking about that.
Okay.
And then the Uno switch card where it's all going around.
Yeah.
Yeah.
Clever. What's your plans with this project? Is it going to be open source?
Oh yeah, I'll release the files now that I know that it works. And we've actually tested it. I think this is only the second time we've like really fully tested it. Because there was one weekend like 2 weeks ago, we set up a bunch of gear and you did some demos, and then I tested it like very simply with just like a MIDI pedal, just sending like a signal out to a synth. So now we really like have put it through its paces and we know it works. So I'll release the files and yeah.
Cool. We'll do more testing with it, but it's a bit of a personal project, right? It's not really.
No, it's not.
But,
it's totally a personal project.
Yeah, but it's what this segment is supposed to be like. What are you prototyping? And this is kind of what you're working on, personal wise. You got your Blitz City thing. By the way,
logo.
Liz has her own YouTube channel called BlitzCityDIY. She's been doing it for I don't know, like 6-8 years or something.
Oh gosh, I think it's gonna be coming up on 9 years.
9 years of BlitzCityDIY. I have a link in the description of the video if folks want to subscribe.
Yeah.
You just released a video on your pocket operator MIDI.
Yeah.
Adapter device.
Yeah, so that
that
does use CircuitPython, and it's a pocket operator by Teenage Engineering, which are these like kind of little desktop synths, and I soldered basically directly to the buttons and made using a KB2040. As I said at the top of the show, I love a KB2040, where it would take in MIDI over USB, and you'd be able to control the sounds on the pocket operator. And you did a fun finger drumming demo with it, which was really cool.
Yeah, it was a lot of fun. Yeah, I've always liked the pocket operator, but I don't like to operate the pocket operator, if you know what I mean. Like I feel like it's a little outside of my
it can
range.
be a little weird.
I'm a big fan of pads and those little buttons. Like it just don't like to touch them. So that I have released the files for the pocket operator, so that's available on GitHub. And I kind of made a repo kind of similar. If you've ever looked at our Learn Guide repo for Adafruit, how like it's one repo, but it's all the files. I'm going to start doing that with my own personal PCB on my GitHub account. Which is BlitzCityDIY?
BlitzCityDIY.
Okay.
And I think it'll be the most recent repo, so it should show up there maybe.
PCB projects?
That's me. Yep.
Okay. Yeah, so folks want
and then
pocket operator.
And
there it be. Your code.
Yep,
CSV. Ooh.
Yeah, because I had to measure the way that the pocket operator sends out voltages to like control the notes is with a trim pot. So I measured which voltage was associated with each note, and I made like a spreadsheet for my own reference. And then I'm using a DAC with CircuitPython to send those voltages out to kind of bypass the trim pot. So that's what that CSV is.
Cool.
Yep.
All right. Yes, Liz designed the roundabout in Eagle CAD.
Yep, I use Eagle.
How was the routing and everything?
The routing was like a little confusing, only because if you've ever done stuff with MIDI where you're having to think about like which way the signal's going, I was like trying really hard to make sure I was sending them in the right spots. And I actually drew out a diagram on paper. I'm more of like a tactile person, and like I actually drew out like a shape for the switch, and I was like, okay, if this signal's going here, it will need to go here. And that helped me kind of stay on track. I think if I'd only done it in Eagle, I probably would have messed it up. So definitely drawing it out with like a big diagram so I could see, and also not thinking in like schematic language, but thinking in just like, okay, this little signal's going here. It helped me kind of stay on track.
Yeah. Let's see. How did you find the switch?
Yeah.
How did you find parts as well?
If you aren't aware, Lady Ada does this fun segment called The Great Search with DigiKey, where she shows how to find. Is this still playing?
No. We would have heard it through the headphones.
Oh, that's right.
So,
well, either way.
Yeah, sorry if you heard just bloops while Liz is talking.
They're beautiful bloops, but
yes.
So Lady Ada does this cool thing where she goes on DigiKey and she has a part she needs to find, and she shows how to use the DigiKey search interface to find the part that she needs. And so I basically did that trying to find that switch where it was like, okay, I need this switch to be able, I'm switching two signals, right? Because there's the sync and source for the MIDI signal. And I need to be able to send it to 3 different ways, right? So it was finding a switch that had basically 2 sides and then 3 positions. So I was able to use DigiKey to do that. And then I was also like, I want it to be surface mount. I want it to be latching. And so then I found these little switches. And then I was able to check if JLC had it available for PCBA, which is PCB assembly, where they will place the parts and solder them for you. And they did, which was lucky. And then the other thing, on DigiKey for the part, they had an Eagle part for the switch. So I didn't have to make a custom footprint, which I've had to do before, and like it's fine, but if it's just available, that's like fantastic. So by doing that, they were able to place the switch and also the little 0805 surface mount resistors, because you need a 220 ohm resistor when you're doing MIDI through. It's part of the MIDI spec. And it was able to place those parts. So then when they came, they look exactly like this. And I have a bunch of like through hole MIDI jacks and 3.5 millimeter jacks for the TRS MIDI. So I was able to just solder those in.
How did you find a pink one? Like, where did you get that?
I bought those in spring 2020 because everything was like shutting down and I knew I was going to want to do a couple projects. So I did a huge parts order from DigiKey, and part of it was I ordered the pink jacks. Yeah.
Wow. Did they come in a reel or in a baggies? Or something?
I think they're just in a baggie. Yeah. But there are a lot of pink parts out there. I did another PCB a little while ago that takes 9-volt guitar pedal and converts it down to 5-volt USB. And I found a pink DC jack for that. So if you look hard enough, you can find
pink stuff.
Yeah.
All right.
Yeah.
Cool. We like JLC PCB. They're great. PCB Way is also another one.
Yep.
I'm
use
not
both.
sure if they use it, but you were able to pick your own color and.
Yes. Yeah. I tried yellow because I'd never done the yellow before. So
yeah,
I figured why not.
Looks good. Yeah. Matches well with the pink audio jacks.
Yeah.
That are not audio jacks. They're also audio jacks. Cool. Yeah. It's always surprising when a Rev A of something works out of the box.
Yeah. Especially I tend to want to like breadboard things that I'm trying out, but I didn't with that. I just tried it out on the fly.
Yeah.
So it was risky.
Right. And you chose to through hole mount the DIN 5 and the TRS jacks just because you had them on hand, but you could have had them make solder it all up for you if you wanted.
Yeah. Well, the only thing with that is if I would have had to find surface mount parts and footprints.
Oh, they don't do through-hole parts?
Well, they would, but when you're doing PCBA, you have to think about what side they're doing the soldering on. Okay. So by doing surface mount here and then through-hole here, it becomes a 2-side assembly, which is more expensive.
Oh, okay. So you saved on
so
yeah.
I would want to do surface mount parts on this side so that they're only having to do one side.
Okay.
So.
How long did it take you to design it?
It was like 1 night, 2 nights I was working on it.
Wow.
Yeah. It's pretty quick.
Well,
you kind of get in a zone when you're routing where you're just like, and you almost like don't want to stop because you don't want to lose your context of like what you've routed and why you've put traces in a certain spot. So I try to do it kind of in one sitting, which is maybe questionable.
Okay. Cool.
Yeah.
All right. Any more questions? Let us know. But we got about like 8 minutes until the show ends.
One thing I talk about is like you can see the text and stuff on the PCB. Adafruit has a fun repository called Adafruit Penguin, which lets you use custom fonts within Eagle. So it's a script that runs, and because you can do an SVG output of Eagle, it can then kind of inject the fonts, and all those little graphics are actually emojis. So I'll do one text layer that's using the emoji font, and then that's how I can get all those like little graphics on there. So it's kind of a nice way to get PCB art with like minimal effort.
Yay, we love PCB art. That's one of the cool things you can do with PCBs is to make some fun silkscreen.
Yeah.
In JLC, can you also choose the color of the solder mask?
I don't think so.
Silk screen. Right?
Yeah, I haven't found that option.
It's
at
just
least.
white then.
Yeah.
Okay.
Well, I think that if you do white solder mask, then it's black silk. But I don't think you can do black silk outside of that. I haven't seen the option at least.
Can't do black on black.
No.
Oh man.
No.
I want a black solder mask and black silk.
Okay.
Cool. I'm glad you had mounting holes. Maybe we'll make a case for it.
I love a mounting hole. Yeah, I've requested a case.
Yeah. Well, gotta do the show.
I've done.
Let's check in on Discord. What's going on in Discord? We got all the questions here. Time to order another RP2040 device. Love the excuse. Please use your coupon code.
Absolutely.
Which is, I wonder what that coupon code is.
Oh, yeah.
Solenoid.
That's right.
That's right. Great. Thank you for that duester. Squid Dodgy learned to type on a real typewriter. Mom got it for his birthday. Oh, that's a sweet story.
Yeah.
Yeah, we're all due.
Speak for yourself.
Yeah. Yeah.
Actually, it wasn't that long ago when you think about it, the typewriters were still in use.
Hence the Mad Men reference.
Yes. Yeah. No solenoid drives in the parts bin. Out of stock. Yeah, they'll come back in.
They'll come back in, yeah. But thanks for everybody for buying them up. Yes.
Is cool in theory, but it's clunky. Yeah. And I feel like once you've done like one jam on it, then you've kind of done all of them.
Yeah.
Like it's hard to be, original with it.
Yeah.
And then a lot of them are kind of based on the idea of sampling, which for me personally, I'm not great at making music that way, but folks are into sampling, then they seem to do a little better with it.
Yeah. It's a cute, some of them are $50, right? The cheapest one.
Yeah.
And it's a cool nod to synthesizers.
Yeah,
but
totally.
doesn't like break the bank.
Yep.
And it's still kind of like, it's pocket. It's supposed to be portable.
Yeah.
It's supposed to be fun. Dabble in with like making music.
Yeah. It's a unique way to make music too. So it's like kind of like a way to kind of stretch your skills.
Yeah. Fun sketching tool, I guess.
Yeah.
Cool. All right. Well, again, coupon code is Solenoid if everyone wants to put any orders in. This has been a lot of fun.
Yeah.
Should we close it up?
Sure. Yeah.
We still got 5 minutes. What else
got 5 minutes.
Talk about?
What's up next?
In terms of projects?
Yeah.
Yeah. So I actually have to pick a project.
Oh.
I haven't picked one yet.
Okay.
That'd be like asking you, what are you doing next?
I don't know.
right? We don't know yet.
Well.
Normally when we finish a learn guide project, we take a couple hours to figure. We have a long
Yes.
list of projects. We
Always.
just have to pick one and see what makes sense, what interests us.
Yeah.
And kind of.
We also look at what's new in the shop, which Wednesdays there's usually a new product drop. So
yeah,
we'll kind of go from there.
Yeah. But I think we're all set with solenoid stuff for now.
For a while.
Yeah, Pedro's doing a top secret thing, so we can't talk about what he's working on until we learn more about it. Speaking of MIDI stuff, I'd like to do. I'd like to turn this project. Let me see if I can get it full screen here. I'd like to turn this into an actual synthesizer using Synth.io. So what I'm holding in my hand for folks that are just listening, this is the USB key set from last week, I believe. Mm-hmm. Was it last week? No, it was 2 weeks ago. 2 weeks ago. Yeah. So it's our remake project. It's our reimagine USB key set from the Xerox Palo Alto. Yeah. Which is it's supposed to be like a keyboard device that allows you to do chords for making like macro stuff and phrases and stuff. Mm-hmm. So I like the mechanics of it. It's using chalk keys and it's all 3D printed. And what I'd like to do is turn this into, like I said, a Synth.io synthesizer where we have maybe a display, some potentiometers. We can create sounds, and then maybe use one of the feathers that has a built-in amplifier, so we can have a built-in speaker.
The prop maker.
With a prop maker, maybe. What else do we want to do with it? Maybe it does MIDI out or something.
Maybe.
I don't know.
I think it would be a good drone or chord machine just because of the form factor. It kind of reminds me of like the organ pedals.
Yeah, like a mini version of that.
Yeah.
Yeah. So that's kind of what I'd like to do. We'll see if Lamar's into it because it's not on the list. It was just kind of like, this has been sitting
Might be
here
like a
for
side
bit.
project.
Maybe, yeah. So we'll see because synth stuff is on the mind. Mm-hmm. So we'll see. Nope. Next week we will have all the regular segments, including Rapid Render. But this week is the special edition with Liz Clark over here. Okay, I think that's it.
Yeah.
All right. Later tonight, starting off with Show and Tell at 7:30 p.m. Eastern Time, is Show and Tell. I think Lamore and Phil, Mr. and Mrs. Lady Ada, they'll be hosting tonight. So we invite you to come by a little bit before 7:30 p.m. Eastern Time. Come on by the Adafruit Discord server, where we'll drop in the StreamYard link, and we'd like to see your projects.
Yeah. We're gonna come by and demo the MIDI Roundabout again.
Yeah.
Yep.
And we'll see what Lamore and PT think.
Yeah.
Actual engineers. Mm-hmm. But then at 8 p.m., right after Show and Tell, is Ask an Engineer, where you can ask your questions, I think, at the end of the show. Mm-hmm. And you
can also post questions ahead of time, too.
Right. Yeah. Amberella will capture those, put them in the queue in the hopper with all the questions to grind out and turn them into answer sausages. It starts at 8 p.m. Eastern Time. I think the Great Search is there, too, or INMPI, whatever segment. We'll have some stuff. We'll hear maybe tariff talk, all the segments,
all of them,
and more. And then Thursdays is JP's workshop. Come on by at 4 p.m. Eastern Time. Find out what JP's working on. I think some shoes, maybe. Fridays is a deep dive with Tim, Foamy Guy. Deep dives starts at 5 p.m. Eastern or 2 p.m. Pacific, where you get some CircuitPython happenings. And then that's Friday. And then Sundays, usually we have a From the Desk of Lady live stream. Mondays is CP Weekly, which might change. We'll see. But those are on Monday at 2 p.m.
Yep, 2 p.m. Eastern.
Okay. And then Tuesdays are JP's Product Pick of the Week, where you can get up to 50% off select items.
Yes.
This week was a USB can feather?
Yeah, it was the Feather M4 can feather.
Can bus.
Yep.
Cool.
And we're back.
And we're back to Wednesdays with all the shows. Don't forget our coupon code. Please use it. We also have another one tonight. Expires midnight.
Yep.
At some time. Cool.
All right.
All right. Thank you, everybody, for listening in and folks watching on the archive.
Thanks for having me.
No problem. Thank you for showing up.
It's really fun.
You flew out from wherever you're from and
flew over from the couch.
Yeah. Yeah. Look at her background. It's a very musical background here. You got your guitars, you got your amplifier, your OK synths.
Yeah.
All the things.
Little music corner.
All right. And if folks want Liz to do her own show, don't bother. Just kidding.
Thanks.
That's gonna do it for us. Pedro will be back next week. Yeah, maybe we'll do this again sometime.
Yeah, it'd be fun
when it makes sense.
Yeah.
Cool. All right, folks.
Thanks, folks.
See you next time.
Right. Bye.
See you tonight. Bye. You play us out with a synth jam?
Sure.
All right, hit play.
Oh.
You have to switch it.
Sorry.